Hi, I'm Sebastian Hueber, and this is the video presentation of Headbang, an interaction technique to trigger actions on mobile devices with head gestures, like this. Touch is the prevalent input modality on mobile, but since it does not detect different modes, such as right-click, its expressiveness is limited. Together with the compact screens and few on-screen buttons, this often leads to context menus that are activated by long pressing. These examples from stock iOS apps show how large those menus can be. And on the right, we even run into a reachability problem for the upper items. So we thought about ways to augment touch interfaces to make this a little better. Headbang. Here's an example for sharing a photo with Headbang. The user touches and holds an image. Then he slightly rotates his head away from the screen and back again. As soon as a gesture is detected, an indicator above the image displays the selected action. To confirm this action, the user lifts the finger of the image. Cancelling is possible by sliding the finger away. This all works with the phone's front camera. While using the screen, the user's head is typically oriented towards it. With the camera and the head tracked in one coordinate system, we can cast a ray from the head onto the device plane. By that, we are breaking down the three-dimensional head rotation to a two-dimensional intersection point. When the user now touches an item, the camera activates and saves the initial intersection point. While the user is touching the screen, a buffer of points is filled. The points with the farthest distance to a starting point is used to calculate the angle on the device. We tested our implementation with arbitrary angles on an iPhone X and had an absolute error of around 11 degrees without feedback and including the human error factor. Therefore, multiple discrete selections are possible by using head gestures. In our first study, we evaluated tracking robustness of Headbang and asked participants to perform Headbang gestures while sitting at a table and walking around obstacles. Even without feedback, we measured success rates around 95%, proving that Headbang can reliably be used on commodity smartphones. So far, we left out the graphical UI and feedback, even though they have a beneficial impact on performance. So let's come back to the context menus. In our second study, we asked participants to select specific items from menus with 8, 12, and 16 items by using Headbang and other techniques. In the Headbang condition, the menu items were selected by head rotations. With device tilt, the participant rotated the phone to select an item. We also tested the same pie visualization with touch and a conventional list menu as we know from iOS. In all conditions, the selection was confirmed by lifting the finger. Apart from device tilt, all input techniques consistently delivered high success rates, which makes them feasible for usage in mobile devices. But with a success rate of 98%, Headbang significantly outperforms device tilt while being similarly precise and fast as the conventional touch-operated list menu. Together with the positive feedback we received from our participants, we believe that Headbang is a promising way to trigger actions from menus across different use cases. It can be operated one-handed and with limited thumb movement. Experts can skip visual feedback to speed up the interaction, and if we want to display a complete menu with many options, the Headbang menu remains compact and preserves the context. Thank you for your attention.